right, well, here we go. It's about time we started talking about what's going to happen for tests and for the AP exam and also for our class. You know already that our tests are going to be like the AP exam. They're either going to be multiple choice or they're going to be free response questions. On the exam, there are 4 free response questions and 100 multiple choice questions. So our tests are going to emulate the AP exam, so we'll get an understanding of what they're looking for, which will also tell you what I'm looking for on my exams as well. Your textbook does a great job of telling you how to answer the free response questions. It does a great job on a lot of things, those introductory sections, and definitely worth a look. Here are the basics of it. In the free response questions, you're always going to be using prose, meaning full sentences are always called for. They won't look at anything that's not written in a full sentence. That's what they're looking for. That's what I'll be looking for. There are key words that they're going to have in their questions. Maybe identify is one of them. And with identify, you might think, well, I'll just bullet it. You won't get credit for that if you're just bulleting it. Identify, but also give an explanation. So they want a full sentence answer on that one. And your textbook gives some great examples of what they mean by identify and moving one step up from identify when they talk about describe or explain. So describe or explain is going to call for a few sentences now. Identify you could probably do with one sentence. Describe or explain is the next step up, and they want a description. They want an explanation. It might take a whole paragraph. 2-3 sentences are probably going to do it. Don't get too wordy in your answers. Don't throw words in there just to throw them in. But chances are you're going to be making a lot of different connections in this class between a lot of different topics. So don't take it for granted. Let them know what you know. That's what they're looking for in their free response answers. Okay, the next step up there is from describe or explain is discuss. So now they want a discussion. This is probably going to be a good solid paragraph, given some good connections between the different topics. And again, please look at your textbook for some good examples. But just to get an idea as we're moving up here. The highest level is if they ask you to write an argument. Now they want the discussion, and they also want your thought process into why you are taking the stance that you're taking. Write an argument would be the highest level of question that they'd be asking. Okay, so that's the free response questions. And another type of question is they're going to ask. One of them is going to be an analytical free response question, and this is going to involve calculations. So in this presentation, I want to show you what they're looking for when they ask for calculations. That's the analytical questions. But I'm also going to use this to talk about energy matters as well, because it's a good time for us to start talking about it. It's so important to our class, how energy is measured and how those calculations would go. All right, so first of all, some energy basics. If you took physics, you already know energy is the ability to do work. And if you didn't take physics, now you know also. So a good reminder or a good introduction for you. Energy is the ability to do work, and the unit that we'll talk about for work is the joule. Okay, because energy and work are related to each other, energy is also measured in joules. If it takes 100 joules worth of energy to do 100 joules worth of work, you can see where those units would be the same. So energy and work have the same unit, the joule. Power is how fast you can do the work. So power is starting to get into the idea of what we're going to charge you for your electricity. And that's the main energy that we're going to be talking about is electrical energy and the different ways we go about getting it. Okay, so for power, the unit is going to be the watt, and a watt is really just the number of joules per second, the amount of work that you can do per second. Okay. So work or energy is going to be determined by how much power you use and how long you use it for. Okay, so here's an example. How many joules of energy are lost in an incandescent light bulb? An incandescent light bulb is the old style light bulb, and those things got pretty hot, and really this is about the number here. They were only 5% efficient, meaning only 5% of the energy was going into giving you light. The rest, or most of the rest, given off in heat. So here's a question. You might have an idea on how to solve this, you might not, but I'm going to be pointing out the way they want to see their analytical problem solved. Okay, it's going to be analytical. And by the way, no calculator. They expect you now to do them without calculators. But when you're doing your numbers, they want you not just to do the numbers in your head, they want you to show what you're doing. And if you're multiplying or dividing, they don't want to just see the number. So here I'm indicating that 60 watts is 60 joules per second. If I just had the number 60 in there, even if I correctly used it in the calculation, I wouldn't be getting the credit, and you won't either on the AP exam or in our class. We're going to start doing it that way. All right, if 5% is used and I'm looking for the amount that's lost, here's one way of looking at it. There's other ways of looking at it. But I could say with my percent that there's 0.95 joules lost for every 1 joule used. And that would certainly be a good ratio here, setting up the 5% efficiencies, meaning 95% lost. But again, I could have done 95 over 100 if I wanted to. That would have worked equally well. But I'm not just going to throw up the number. I'm going to also indicate why I'm doing that. 0.95 joules lost for every 1 joule used, and that's why I'm multiplying by 0.95. That will give me the number of joules that are lost per second. I don't want the joules that are lost per second. I want it for an hour, so I'm going to add one more step up here to cancel out my seconds. There are 3,600 seconds in an hour, so seconds will now cancel out top to bottom. The number of joules are going to be canceled out here, used, and I'm going to be left with the number that are lost per hour. So go ahead and try that without a calculator, give yourself some practice, and if you do, the answer you should get is this one, 205,200 joules lost every hour. So there's the correct setup. If you have the correct answer but not the correct setup, oftentimes they won't give you the setup point. On the other hand, if you have a correct setup, but then you did the math wrong, you'll still get some points. So it's worthwhile to do it for a lot of reasons. So that's the correct setup we'll be looking to show. To go further, and I'm going to be explaining in class how you can use scientific notation to your benefit when you're working without a calculator, but here are some things to talk about. Kilowatts. That's good for talking about what a home is doing. Megawatts and gigawatts, 1 million and 1 billion respectively, are good for talking about the capacities of power plants. So energy itself for households is billed in kilowatt hours, the number of kilowatts per hour. Okay, so let me give you an example of that. Here is an example using the kilowatts, talking about a real-world type of problem, the type of thing they might ask on an analytical question, and also giving you the chance to show the setup, the proper setup. So the setup, of course, here is going to involve an explanation for why I'm doing what I'm doing. So I'm starting off with my 15 cents, or $0.15 per kilowatt hour. I'm going to multiply it by the 900 kilowatt hours per home per month, but I'm not going to do it without showing why I'm doing those numbers. So far, my kilowatt hours are going to cancel out, and that'll give me the number of dollars per home per month. I don't want the number per home. I'm looking about the number for the town, and that means I will multiply it by the 10,000 homes that are in there, in the town. Okay, so maybe you want to see how you did on this one, but when I got the answer, it turned out to be $1,350,000 per month that the town was spending on electricity. So think about those answers, think about what they mean. As always, think about what's presented and think about other connections that you could make. What other questions could you ask? Everything that you do raises other questions. Start thinking about making those connections. Well, I hope this was helpful. We'll talk a little bit more about it and any questions you have in class, and I look forward to seeing you there.